No chance of mixing that up because that's not there at all. Variance is not there at all. Okay. The lengths of human pregnancies are normally distributed. Again, population 268 days, standard deviation 15. What is the probability that a pregnancy lasts 300 days? Anybody see any mention of a sample there? Is this a sample distribution? Did I hear sample? No, it's population, right? Didn't say anything about sample, right? So this is just simply a matter of figuring out what the z-score is, and then getting the area for pregnancies that are 300 days or more. Remember, again, we got to parse this. We got to figure out. We got to look past all this information and say, well, the important numbers here are the mean, the standard deviation, the fact that it's a population, and we want the percent likelihood of 300 or greater, at least 300, right? So in order, remember that's the right tail of the curve. So if our table only gives us the left tail of the curve, we got to remember not to forget to subtract from 1. Find the mean and standard deviation of the sampling distribution of the proportions. Okay, now I know in the last lecture you discussed sampling distributions of proportions. So now let me pull this back up again. Oh, wrong one. Okay, let's talk about sampling distributions of proportions. Okay, so now we may have a situation where we're looking at 20% of a population has a disease. And we want to know what's the probability that if we take a sample well, we might want to understand what the that this is our prevalence. We want to understand what's the sampling distribution for this population for a sample of size 100. Okay, let's take a look at that. First of all, we know that if the whole population is 20%, right? If I take one sample of 100, I might get exactly 20%. Take another one, I might get 0.19% of the people in that sample have disease. Take another one, it might be 0.22. Take another one, it might be 0.195. Take another one, it might be 0.23, and so on and so forth. But I know that the largest, if I take sample size of 100 and it's really a prevalence of 20%, I would expect 20% to be the most frequent result of that sample size or numbers near it. So I would expect the results to be a normal distribution. Okay, except this time, instead of a mean like a number 70, right? Instead of that, I have a proportion. Half the time I'll find results below 20%, half the time I'll find results at 20% or above, right? So it's a normal distribution, it's symmetrical, and so on and so forth. It's a little bit different, but in this case, our mean, our p-value for our population is 20%. Our p-value for our distribution of samples of size 100 should be equal to 20% also, just like our mean of our sample distribution is equal to 20%, approximating the population mean, right, is also 20%. I put a cap on it to indicate that it's a sample proportion, sample distribution mean, right, rather than the population mean. Okay, so now what I need to know in order to make any kind of judgments about this is how to figure out a standard error or a standard deviation for this distribution. Well, in this case, we use a slightly different formula. It's the square root of p times 1 minus p. Sometimes you'll see 1 minus p shown as q over n, right? So you can figure out, well, that's going to be 0.2 times 0.8 over 100, right, which is 0.16 divided by 100, which is equal to 0.0016, and we want the square root of that whole thing. Right, so now it looks disastrous right now, but don't worry about it. It's going to get better because when you find the square root of a fraction, you actually get a bigger number, right? Because let's see, 0.0016, take the square root of that, and it's 0.04. So the standard error is equal to 0.04. So in other words, one standard deviation above and one standard deviation would be 0.24, and this would be 0.16. And just like other standard, other normal distribution, we can make certain assumptions about the areas here. Okay, so point that no 0.04, right? 0.04 times 0.04 is equal to 0.0. Remember, it's four decimal places, 0.0016, right? Two decimal places and two decimal places. So it's going to wind up 0.0016. Okay. All right. Let's see. Can you go back to the previous problem? Okay. Assuming I remember the previous problem. Are we talking about question number 14? Is that what we're talking about? Question number 13. Okay, hang on a second. Question number 13. Okay. One reason is okay, you got to parse this down to to just the details of what's going on here. What's the mean? The mean of the population is 1050. The mean of the standard deviation of the population is 21.8. Describe the center and variability of the sampling distribution. What's the center going to be? Anyone has to guess what the center is going to be? Remember, the mean of the population is 1050, so if it's a sampling distribution, it's going to be the same thing, right? It's going to be 1050 also, right? We expect that if we take samples over and over again, we'll get the same sample for the samples, same average for the samples as we get for the population. Okay, now what's the variability? In other words, what's the standard deviation? I think I went off on too much of a tangent there with the distinguishing variance and variability. By variability, they usually mean standard deviation. What's the standard deviation of the sampling distribution? Well, we know the population standard deviation is 218, right? So we got sigma, right? So we got n. So we know what the population standard deviation is. I'm sorry, I missed. There was a y there. Why is the sample size the same as for the population? Okay, that's a fair enough question. Okay, let's say I have a population of 1,000,000 men, right? And of those 1,000,000 men, the average weight is 150 pounds, right? If I take a sample of 100 people from this population, right, I would expect, and I take the average, mu, the whole population, if I take a sample of 100 people, what would I expect the average to be for those 100 people? I would expect it to be pretty close to 100 pounds, right? Because that's the average for the entire population. Now, sometimes I may get 95 pounds, right? If I take a sample of 100 again, I may get 110. Get a sample again, I may get 199. Get a sample again, I might get 101. Sample again, I might get lucky, get exactly 100. If I take all of these samples and draw a new distribution, well, half the time I'm going to get an average below for a sample of 100. If I just look at the average for each one of those groups of 100, and then I plot them here, I would expect to get half the time get a value below 100, half the time above 100. But on the average, I should get 100 for if I do it enough times. I'm sorry, 150. Yes, 150. Right, sample size was 100. And if I want to know, if I knew what the standard deviation of this population was, standard deviation of this population, let's say it was 10 pounds, sigma for the population, then the standard error for this distribution would be 10 pounds of sigma over the square root of n, or over the square root of 100. That's going to be 10 over 10. It's going to be 1. Standard error is going to be 1. Right? So in other words, the standard deviation, the spread for these samples would be for 150. Sometimes I get 149. Right? In other words, 68% of the time I get 149 to 151, and so on and so forth. Okay, so that's what we mean by that. Let me go back to where I was here. Let's see. Let me see which one. 15. Did I get through 15? Yeah. Assume that 26% of students wear contact lenses. We randomly pick 300 students. Describe the sampling distribution model of proportion in this group who wear contact lenses. Sounds awful familiar, doesn't it? Okay, 26% of students at a university wear contact lenses. We randomly pick 300 students. Describe the sampling distribution of the proportion. So now that's the sample, that's our p-value is 0.26. So p cap, our average for our sampling distribution, just like our mean, is going to be approximate that as well. But what is going to be our standard error for our sampling distribution? What's going to be the spread there? Let's think about that. Remember, for a proportion, rather than sigma over the square root of n, use the square root of p times 1 minus p over n, right? So that should be pretty simple to figure out. Okay, let's look at these. According to a survey on drug use, 54% of males have never used marijuana. Based on this percentage, what is the expected number of males who have used marijuana for a sample size of 100? Okay, so now this is kind of gives us a lot of extra information that we don't need, right? Based on what's the expected number of males who have used marijuana for a sample size of 100? It didn't ask me about percentages, right? It told me percentage of males was 54%. I'm going to change that. I'm going to call that 70. According to the survey, 70% of males have never used, I'll say females, 70% of females have never used marijuana. Based on that percentage, what's the expected number of males who have used marijuana for a sample size of 100? Okay, so if 70% of females have never used it, what percent have used it? Pretty simple, right? 30% have used it. So, what's the expected number of females who have used marijuana for a sample size of 100? Well, we just said 30% of females haven't used it. So, if you take 100 females, we would probably expect 30% of them haven't used it. So, 30, right? So, you can figure it out for yourself for the actual problem they give you there. Identify a type of observational study, retrospective or prospective. An examination of medical records of 10,000 women showed that those who were short and fair skinned had a higher risk of osteoporosis. An examination of medical records of 100,000 women. So I'm going to leave that up to you to decide whether an examination of medical records is forward looking or retrospective. Okay, so I'm not going to answer any. You got to answer the question yourself on some of these, at least anyway. I would hope. Trying to do this without giving up the ranch too much here. Identify the study as observation or experimental. A TV show's executive. Give me an example. Somebody give me an example of an experimental uh, 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 survey, experimental study. What might an experimental study? What might an experimental study look like if you were to do an experimental study? Okay, okay, eating donuts raises blood sugar. Okay, so how would you check if eating donuts? You check if somebody's eating donuts. If eating donuts raises blood sugar in adults, you check that not by having one group, right? Because you'd be concerned that, well, gee, maybe the tea they drank with the donuts might have made them. You use random. You take a sample of people, you assign them randomly to a couple of groups, you expose them to one thing, you don't expose the other group, right? You might have placebo donuts. How about placebo donuts with no sugar in them, right? I don't know how that would work, but that should be interesting. That's an experimental study, right? Yeah, exactly, us, right? So that would be an experimental study, right? Observational studies, well, we did surveys. Didn't we just do a survey where we asked you what direction, whether you're male, female, what direction you stand in the shower, and so on and so forth? That might be an observational study, right? You go and check just survey data and stuff like that. So um, you can make your own judgments as to which way you want to choose on there. Okay, Let's see. Find the indicated probability for normally distributed variable. The weekly salaries of elementary school teachers in one state are normally distributed a mean of $490 and a standard deviation of $45. What is the probability that a randomly selected school teacher earns more than $525 a week? Okay, first thing, is this a population that we're dealing with or a sample? Population, right? So we don't have to worry about calculating standard error and stuff like that. So now we just have to find the z-score, and we have to find the percentage. Again, they're asking for more than, so we know if they're asking for more than, they're asking for the area to the right of that point. So right of that z-score, whatever it happens to be, our table gives us the left, so we got to remember to subtract from 1. That's the only tricky thing there. In a clinical trial, 780 participants suffering from high blood pressure were randomly assigned to 3 groups. This sounds like an experimental study. Over a 1-month period, the first group received low doses of an experimental drug, the second group received a high dosage of the drug, and the third group received a placebo. The diastolic blood pressure of each participant was measured at the beginning and the end, and the change of blood pressure was recorded. The biggest decrease in blood pressure was for those who received the low dosage of the drug. What is the benefit of randomly assigning the subjects to the treatments? Okay, now why do you think you in an experimental study, why do you think you randomly assign subjects to different groups, to like a placebo group and a test groups? Why don't we use Excel for the problem with the teachers? Uh, da, da, da. You could use Excel to find the no. See, it's normally distributed, so it's a normal distribution. So you're finding a z-score, right? And a the z-score and the probability associated with that z-score. It's not a binomial distribution. You could use Excel if you want to look up the normal distribution for whatever calculate what the z-score is. Different, like the difference between the value you're looking for and the mean over the standard deviation, the z-score. You could look that up and then find it to. You feel like there's 2 possibilities here. Probability that random that earns more than 520. In other words, earns more. She either earns more or less than. Well, normally that would be. Remember, there's something missing here in order for it to be a binomial, right? It would have been a binomial if they said we take a let's say that we take a sample of 10 teachers. We take a trial size of 10 teachers, right? So we take a trial size of 10 teachers. What's the probability that 6 of those teachers made more than $525 a week? That would be binomial, right? So in other words, if I were to pull up Excel, let me just pull this up. If I were to pull up Excel and do a binomial distribution, equals binom dist, parentheses. Okay, what's the number of successes here? See, in other words, when it's a binomial distribution, right, you would be looking for, well, how many people out of the number of people that they sampled had that condition, given that that the rate at which they have that condition. Okay, so we don't have a probability of making $525 a week, at least not yet. We don't have the number of people that were successes or the number of trials, right? We didn't have a sample size. This is just a ordinary normal distribution. Okay, and actually you could use norm dist, right? Oops, let me get out of that. Equal norm dist, parentheses. And for norm, oops, missed the T. I'd use norm S dist. No, let's do norm dist. Parentheses. You could put in X is the value you're interested in, right? Which in this case is 525. The mean is 490. And the standard deviation is 45. Since this is a population, we don't have to worry about standard error. Okay, and cumulative, if we put true in there, it would give us the probability or the percentage of people that are have a salary 525 or less. But since they're asking for more than that, we'd have to subtract it from one, right? So you could use norm dist if you wanted to. It's not a binomial distribution, because a binomial distribution, you'll always see like a situation where you have a number of successes and a number of trials. For instance, another example might be for this one, you sample, they might tell you that 20% of the teachers make more than $525 a week. What's the probability that if you would take 10 teachers, randomly select 10 teachers, that 3 of them would be making more than 525 a week? See, there you have a sample size, trials, you have a number of successes, 3, and a question about the probability, which would be my binomial situation. Okay, so I'm going to leave number 20 up to you, because you can look that up back on the uh, uh, let me come back to that in a second. Let me get to 21 so I can come back to that question. Um, 20, I'll leave that up to you, because you can look that up in the text, either in the text or in one of the lectures, and so on and so forth. And also you can reason out why you would use, randomly choose which group that people would be in, and so on and so forth. Um, 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 20 has 2 answers. I that could be a possibility. I have to take a closer look at it. I want to get to 21 before we're running a little bit long here, so I want to get to 21. Select the most appropriate answer. Which of the following is the reason using randomization? Again, this is more of a reasoning problem, kind of similar to the one we just had before, right? What possible suppression to balance uh, uh, lurking variables, to balance the groups on balance group on variables known to affect the response. All of these. Well, first of all, number one, all of these would have to contain none of these. So how would that work? Is it possible to have those two in the same question? That doesn't make any sense, right? Like, kind of an odd way to phrase a question, right? But at any rate, I'll leave that up to you to figure out. But I don't think it's all of these. I'll give you that. Okay, it's not none of these and not all of these. I don't believe. So, well, let's see. Eliminate possibilities. The balance groups and possible lurking variables. Yeah, maybe you could say all of these. I'm not comfortable. Yeah. I was going to say maybe not all of these, because to balance the group on variables known to affect the response. Well, if you know that there's a variable known to affect response, then you might want to eliminate that before you even do the study. Like, in other words, if you know that smoking, it's a study that might be affected by whether a person smokes or not, but that's not what you're studying, then you might say, I'm only going to use non-smokers, right, or something like that. You might, that's the only reason I'm thinking maybe not. I don't like the all of these. Also, how could it be all of these if one of the answers to all of these is none of these? Can't be none of these and all of these at the same time. However, I think that's a problem with the structure of the problem rather than with the answer. Um, yeah, I agree with you. It's at least two of them, maybe all three of them, depending on how you think about the problem. But in order to answer all of these, don't you have to also say it's none of these? So I would guess mean all of these except none of these. But I'm getting a little too far off base on this, I think, right? But it's interesting, right? Oh my God is right. So at any rate, yeah, I think it's going to be at least two of these, right? But maybe all three of them. Okay. Okay, I agree. I probably would too. I probably would put all three. So at any rate, okay. So let me go back to yeah. Somebody had a question back there. Hang on a second about the z-score. I lost track of it. Lost track of that question. Okay, so now this isn't a psych class, yeah, exactly. Okay, so I think if you I don't know if Professor Waldron's going to put in any problems using SPSS. I'm gonna post later on maybe an instruction sheet on how to do some quick calculations in SPSS. And let me just see. Let me just go back over who's on this session right now. Okay, I'm gonna maybe put together something quickly on SPSS so that like if you had any quick questions in the head and tail question, the complement was not yeah AC is a typo. Yeah, it should have been a capital C. It's a typo in the sense it should have been a superscript C, A with a small c on the top, which means not C, not A. I think that's a good question. I'll make sure that they know that there's an issue with it and that you should get credit for it as well. Da, da, da. Are we going to get credit for PPV question? Am I right? That would be a 10-point credit. Yeah, because I guess they're 5 points each, right? With one extra question. Two different equations for standard error and when to use them. By two different equations for standard error, you mean for proportions and for regular numbers? Square root of p times 1. Yes, that's okay. Let me pull up the sheet here. Where's my note? Was that? Let me get rid of this stuff here. Get it out of the way. And let me make sure I answer these questions. Conditional probability, calculating conditional probability. I think we covered quite a bit of that. I didn't show it using SPSS. I'll do something separate on SPSS. Use the table, we went over that. We went over the sensitivity, stronger gun control, went over that problem. Find a binomial random variable. Does it want us to find the mean of the binomial? I think that, yeah, question 5, I can't tell which question it is. I calculated my answers of crosstabs. Oh, yeah, we know that and this problem was one that was, I think you're getting credit for anyway because it wasn't in one of the answers. Okay, I don't know which one 15 is. All right, so let me just pull this back up and talk about these different kinds of distributions. Okay, let me show you three different distributions. Okay, number one. Here's the distribution of the mean. Okay, mean is 100. Standard deviation is equal to 10. This is indicated by mu, and this represents 50% of the population is greater than 100, 50% is below 100. Okay, if I take a sample from that population and say the sample size is n equals, and I graph repeated samples from that population. In other words, this is a graph of if I had taken samples of size 25 over and over and over again from this population, what would I expect the distribution of my sample means? In other words, X bar. What would I expect them to be? Well, I would expect them to be 100 also, right? Because if I'm taking it from a population as a mean of 100, then I keep taking samples of size 25. Well, half the time I'm going to get samples that have an average of under 100. Half the time I'm going to get samples that have over 100. The only difference here is that I call this one X bar instead of mu. And it's a narrower distribution because this has all the individuals. You might have somebody that is, and this is the 132 and or 131. Over here it would be 79 or something like that, right? Individuals have very low values, very high values. With this one, you're averaging 25 people. So you're not going to get you're not going to get all 75s. When you take that, at least not much chance of getting at that. So this is going to be a narrower distribution. So its standard deviation is going to be called SD, standard deviation, or better yet, for the sample means is going to be standard error, right, is going to be equal to the standard deviation of the population over the square root of n. Or in other words, 10 over 5 or 2. right? So where 2 standard deviations below the mean and above the mean for the population would be 80 to 120. 2 standard deviations below the mean and above the mean for the sample distribution would be 96 and 90 and 104, right? So now, what about if you got a proportion? Like, in other words, you know that the population has a prevalence of 30% of the population is uninsured, right? So you want to take a sample. You're going to take a sample of 100 people from this population. Okay. Well, there's two ways I can look at this. One way is to have a distribution where I put down the number of people that I get from this population that are insured, that are insured at a sample out of 100 people, right? Well, if I take 100 people from this population, I would expect the most common outcome, in other words, my p-cap, my most likely outcome for a sample of 100 people from this population would be that 30 people are insured. Well, there's a distribution around that, though, right? Because occasionally, if I take 100 people from this population, I'll get 28. Occasionally, I'll get 32, and so on and so forth, right? But it'll be a normal distribution, okay, or close to normal distribution. Okay, so now, if I were to look at that as a proportion, I'm ignoring your questions for a moment because I want to get through this. If I were to look at that as a proportion, and I would say that I would expect my p-cap, my average for all of these samples to be 30%, to be 30% of the people sampled. Well, if I take a sample of size 100, I want to know, well, what's the likelihood that I would get 27% in a sample, or 33%? In order to predict that, I need to have a standard error or standard deviation for this proportion. And the way we calculate that standard deviation or standard error is the square root of p times 1 minus p, right? That would be, in this case, 0.3 times 0.7 divided by n, and then take the square root of the whole thing. Okay, that's going to be equal to the square root of 0.3 times 0.7, right, over 100 is equal to 0.21 divided by 100 is 0.0021. Take the square root of that. It's going to, I don't know, it's going to be, let's say, argument's sake, it comes out to be 0.03. So the standard deviation is 0.03. So 2 standard deviations to the left would be 0.2, 2.24, and 2 standard deviations to the right would be 0.36, right? So 95% of the time, roughly, I would expect that if I take a sample of 100 people from this population, that I'll find between 24% and 36% of that sample is uninsured, right? So let me go back and look at these questions. So P is basically, you would use it just as you would use the mean. Okay, now I understand some of you guys are having some problems with this. For the moment, for the purposes of the test, given the time we have left, try and just, remember that you may not see that much of this on the test. You saw about 3 or 4 problems that are kind of heavily weighted on the homework. You may not see quite as much of this on the test. For exactly what we subtract or add in order to get the shaded areas. Let me back up a second. So exactly what we add or add together. It's shaded once I get a z-squared. Okay, you repeat. Finding 0.27, 0.24. That's 0.24, 2 standard deviations away from the mean. In other words, I calculated a standard error. For a proportion, it comes out to be a fraction, 0.03. And this, I estimated a 0.03. Okay, 2 standard deviations below is 0.24. I don't know if that's clear, right? 2 times that, subtracted from p-cap, and 2 times that added to p-cap. Likelihood of finding 27. I think, yeah, that like if you have kind of a grasp on the homeworks and the exercises, I'm guessing though, because I haven't seen it. Okay, go back to number 20. Number 20. Actually, I'll tell you what. We're kind of running out of time. It's going to be number 20. I didn't really answer 20. I kind of left it up to you guys to answer, right? Because it's going to take a little bit more thought and parsing and stuff. We're kind of running out of time. But think about the reasons that you randomize stuff. Okay, look at the lecture. The lecture notes should help you out on that quite a bit. Um, Uh, Now, a lot of this stuff too, keep in mind that if I put this up on YouTube, that you'll be able to scrub through this. And since I did them in this particular sequence, you'll be able to kind of go to that part of the session if you can remember, like if we did it at the beginning or the end, and just go over my explanation again rather than repeat it now. Click on Z-score. Let's get a Z-score. Go over Z-score one more time. Okay, so now the Z table, like the example we had before, where, and I'm going to change it a little bit. I'm going to say, okay, I'm going to say that we have a distribution. You've determined that you want to find this area in here, right? That's the area you want to find. And the Z-score here is minus 1.88. The area, the Z-score here is plus, I'm going to change this a bit, 1.67. Okay, if I go to my Z-scores, okay, the table always gives me the area from that Z-score to the left. So if I look up the area for 1.67 plus 1.67, it's going to be on the second page. Okay, 1.60, 1, 2, 3, 4, 5, 6, 7, 95.25, right? That area from here down, all of the entire thing from there down is 95.225, I think it said, right? Okay, so now I'm only looking for the area in here, right? So I want to eliminate this part. I want to subtract that part from the 95.25. So I go to my table again from minus 1.88, minus 1 point, minus 1 point, where is it? 1.8 minus 1.8012345678, and that's 0.301. So that area is 0.0301. So I have to subtract 0.01 from 95.25, and it gives me 92.24% is the area between the two of these. That's the way you use that table. Use that table to give you the area from the location of your z-score, whether it's negative to the left of the mean or positive to the right. It always gives you the area from that point to the left, the shaded area. So you have to determine what area the problem is asking you for. Can we view the labs as well? The labs should be on YouTube. The labs, if you go into the multimedia link on the right-hand side, at least the last 3 or 4 labs for sections 3 and 4 should be on YouTube. You should be under that tab. If you click on them, they should play. Send me an email if they don't play. And also on Google Plus, a couple of Ali's labs are there also that all you guys can access also. There's a link to Google Plus on Blackboard as well. So you should be able to see both of our labs. I'll try and get this posted today so that you, or before too late this evening, so that you can get a look at it. Under the Democrats one, that I don't remember. I can't. I don't know. Don't remember which problem. It's opposing out of total democracy. Okay, good. Thank you, Gene. You saved me. Your memory is better than mine, fortunately. Okay, guys, I think we got to call it a day. And I wish you the best of luck on the test. It looks like, well, you want to know, so I posted a message there yesterday. You got to keep an eye on Blackboard. However, the most recent snow totals for tomorrow that I've seen are 3 to 6 inches. They're scaling back a bit. So apparently it's not going to be quite as bad. So unfortunately, we will not have, doesn't look likely we're going to have snow day tomorrow. I'm just as unhappy about that as you do because I'll have to drive into the city. Ollie's Lab on Probability is the only one on YouTube. On the Google Plus account, if you go to the Blackboard and click on Multimedia 003 and 004, I think I don't remember. I don't remember what we covered there because I covered kind of like what the parallel the lab and stuff like that. So yeah, I'll have to check it. I really, besides my labs, I'm not sure what else was up there. Okay, take care, guys. And good, like I said, good luck on the exam, and I'll try and get this posted as soon as possible. Take care. Bye.